Hello, and welcome to this inaugural episode of State Machine Corner. I'm Dr. Bruce Powell Douglas, Principal at A Priori Systems, and Senior Principal Agile System Engineer at the MARTA Corporation. I'm one of the authors of the UML standard and SysML standard as well. State machines are a compact yet powerful means for capturing behaviors of systems and system elements. They can be applied equally to simple systems and complex systems. State machines have rich semantics, and this makes it difficult for many people to apply them effectively. So I thought it would be useful to have a series of short discussions and demonstrations of what state machines are, how to create them, and how to render them in a couple of different tools. In this first episode, I thought it would be useful to talk about the basics of state machines, how they represent classifier behaviors, and actually even build and execute some simple state machines in a couple of different tools, IBM Rhapsody and Cameo from NoMagic. If you like this video, please click the like button. If you want to be notified as more episodes can become available, click the subscribe button. If you want more information, well, I've written, quite a number of books, including the recent book, Agile Model-Based System Engineering Cookbook. You can also visit my website, bruce-douglas.com. With that, let's get started. We'll start up in the Rhapsody tool. So here I've got a Rhapsody project set up. I've actually added some settings, which I use to change line styles and so on. So if you start off Rhapsody in its native form, it looks slightly different than what you see here. Let's start off by creating a block. And we'll call this block timer. Okay. And in the block, we can very simply add a state machine by add new state chart. And now we have a state machine. And we can start adding some states. So states are conditions, right? They're conditions of existence of the classifier that owns those elements, okay? So it's not like an activity diagram where you're modeling the rounded rectangles as states. In fact, they're conditions of that. So one condition is we're ready to do stuff. We'll name this state ready. Let's add another state, which we will call running. And that's where we're doing behaviors. And now there's a way to get from one state to the next, and that's with the transition. We can right-click, click on it, select a transition, and we will add an event, EV start. Typical naming convention for me is that my event names that start with EV, my signal names that start with EV indicate it's an event. So EV start. And then we can go from running back with EV stop. Now we identified a couple of different states and a couple of different events that can transition from the different conditions of this block, right? So you just have EV start, and we start with the running state, and stop, you go to the stop state. Now, because we have more than one state, we do have to indicate where do we start. When we create this behavior underneath the block, and if we do Control L in Rhapsody, we see our block timer here. We see our state machine here, and our state machine is open, and we see here a couple of the events. We just entered EV start and EV stop. Because there's more than one state, we have to say where do we start. To do that, we will add a default transition. And that's where we start. And we can actually run this if we want to. So let's do that. Let's create in our package a new component. We'll add a new component here as an extension. I'll add a component, and we'll call it, here's a component 4. Bring up the specification dialog. We'll give it a better name than component form. and we'll call it timing component. And in the scope, we have the default scope selected, so that's fine. Inside the running component, we see that there's configuration, and it's by default named default configuration. If we look at that, we see that we've got the features dialog. We can initialize it and say, well, let's create an instance of timer or initial instance. And because it's going to generate code and create an initial instance to run, so there has to be something that runs. And we'll set our settings. And our settings, we're going to set instrumentation mode, animation, and we're going to use the Cygwin compiler because that's what I typically use for this. So now we have a component. So now I can actually do GMR, generate, make, run on this component, generate the code. If there's any issues, it'll identify the problems, and we can run this and see if we got it right so far. Because frankly, I'm not very good at typing things without making mistakes. So we'll hit the GMR button up the top. Do we want to create it? Yes, we do. Do a little song and dance while it runs. It's compiling the timer. Doesn't do much, so there's a good chance it's going to proceed without error. It's compiling up the package, the main application. And in a second here, it'll run. So currently, we're waiting for it to now have a virus checker. A virus checker finds a new application that says, what? So we have to wait for it to clear, and that check will go away in just a second. So you have a request. Okay, so now we're running. So now when we run this state machine, it's not doing anything yet, all right? Because we haven't told it to go. So when you start off with animation, it becomes ready to run, but you have to explicitly tell it, say, give it a command and say, go run. So fine, we can do that. We'll say, go run. Now, we can't really see anything going on, very interesting. So let's open up an animated state machine. So we go to instances here under the timer, instances, and we can now open up an animated instance state chart. Zoom to fit. All right. So now I can actually execute this. I can say, okay, well, let's now insert an event. So I can right click and say I can insert an event or generate an event here, or I can use the icon up here to bring up the same dialog. So let's just generate an event. And there's a couple of events I can do because we're looking at this particular block and there's only one block. I see a couple of options, EV start and EV stop. I will do start and I will click on generate. And we see it transitions to the new state. The what I call puke green color indicates the previous state and previous transition. And the magenta color indicates the current running state. I can then select the new event to stop and go back to the stop event and we go back to the ready state. All right. So far, so good. Let's do this the very same thing then in Cameo. I'm bringing up Cameo. Cameo here. There we go. There's Cameo. I created an empty model here. In Cameo, the very first thing you need to do is create a package. So let's go to new elements and we'll create a package and we'll call it same as default. And I'll add EKG. And inside there, we'll create a new BDD, diagram, BDD, optimization diagram. Here's my diagram. Let's make this a little bit bigger. And let's add my new block. We'll call it timer. So here's my timer. I can now select this and I can now add a new state machine. So I can add a diagram. I just add a diagram and I want to do a state diagram. And it adds this as a classifier behavior. Again, that's pretty tiny, so let's make it bigger. And we'll name the state ready. I also want to add a new state, which was timing or running. And we can now add a transition. And we start, and we'll do the same thing here. There we go, transition back, EV stop. Okay, so now we can run this. Now when we run this, we really want to run with context. That's the owning block that owns the classifier. So I can run this. It's asking we're going to add checking rules. That's fine. So we should now be able to run this. We get a simulation control panel down below. We can click on run, and we see we're currently in this state. I can now select the element here, and I can say I want to do start. We transition to the running state. Now here we can select our trigger. We can do stop, and we go back. Well, so far so good, and runs in both cases. Let's transition back to Rhapsody now. And we can stop the execution by clicking pause and then stop. And so let's remove a bit. Well, let's add some more interesting behavior. It's a timer. So let's have it time out every second here. So we'll now add a transition to self. Here's transition. And we're going to go back to here. And we're going to have a timeout. So the timeout we're going to use is TM in Rhapsody. The units are milliseconds, so every 1 second. We're going to take this transition, and we want to add an action. And we want to add a very simple action. We'll just add something like print the current time, right? So we're going to do something like count ++, augment count, and then we want to print it. Well, this is C++, Sigma C++, so we'll do standard output. And that should do that. Okay. Now there's a problem. We're referencing a value count that doesn't exist. We have to add it to our block. We go back to our block diagram. We can do this a couple ways. We'll just go to the specification dialog, the features dialog in Rhapsody. And we'll go to value properties, and we'll add one called count. And it's entered by default to integer. That's fine. And we see, by the way, I have the display properties turned on in my preferences. I can see both the value properties and these event receptions. Right, that's operations. We can go back to our state machine. So count is currently not initialized to a value. I could have given a default value in the dialog, but I want to do it here on the state machine instead. So I will add an action to that. I'll bring up the dialog, and under the actions, the transition actions, I will add count, got to spell right, equals 0 as an entry action. So I can't add events here because it's initial transition. It just indicates which state do we start in, but I can do this, right? So now if I run this, what do I expect to happen? Well, I expect the value of count to be set to 0. Once we start, we will every second update the value and print out the value to the display. Let's see if it does that. So we'll go back and we will now do GMR, generate make run. It's going to compile that up, and it's compiling, generating our components, running. Now remember, when it runs, it'll argue with my virus checker for a little bit. Well, it does that. Fine. But actually, when the Rhapsody runs, it actually generates an application, generates code, runs that application, and because animation is turned on, it instruments the application with information so that it can come back and talked to Rhapsody and tell Rhapsody what's going on. So let me move my application a little bit over to the side here so I can actually see it run. Let's now run this. Now remember, we have a startup state machine here, our running animated state machine. We can now insert my event. This time I will click here, and we see the we've only got one block, so that's pretty straightforward. We can enter the start event that's already selected. We'll say go run, and now we'll start running, and we see over the left-hand side, it's printing out the value. Well, that's kind of cool, right? And then we can send the stop event to have it stop counting. And now transitions back. Oops. I've selected stop event. And it goes back and it stops. Cool. And then we can stop the execution. We can actually do it a couple ways. We can also just stop the application from running. Let's now augment the same behavior in our Cameo model. Here's our Cameo model. It's currently running. Let's go ahead and stop that run. Right. Let's go back to our timer and let's add a value property called count. We know we're going to have to do it, so we're just going to add it, count, and I'm going to have an integer. I'm going to use control space to select the type I want, and the value type I want is an integer defined in SysML. Go back to my timer state machine, and now let's augment the behavior. So while we're running, I want to add a behavior. I can actually just draw a transition to itself, or I can use transition to self here. I'll just do that. And I will do that now with a transition. In Cameo, if I want to have the same tiny behavior, I have to type in after. I'm going to say after 1 second. I want to do this. Now, the reason why I'm doing this in 2 steps, adding the action after the fact, is because the parser in Cameo isn't always as smart as it thinks it is. And sometimes if I say after 1 second / action, it actually names the transition that and doesn't actually properly parse it. So sometimes it does that, not always. So I'm just going to do it in 2 steps. So now that we have that, we will open up the specification dialog for the after transition, and we're going to add a behavior. Now, one of the tricks is it's not called an action, it's called an effect. So here's the trigger. We see it's a time event, and we see its relative time. So the timing event, so is relative should be set to true. Is relative is set to true. If it wasn't, the default timing event is called at. If at a specific time, we just want a relative time event. So is timer is true. And then we go to the effect. So the effect behavior we want is called an opaque behavior. Now with Rhapsody, the default action language is the language you start up. It's C++, it's C, it's whatever, and then you specify the compiler and the component. That's how Cameo works because it simulates behavior. So Rhapsody is actually a stronger execution model than Cameo is, because Cameo does simulation. Rhapsody does true model execution by generating code and executing it. Still, the behavioral execution is strong in Cameo. It's just not quite as strong as it is in Rhapsody. So we're going to specify a behavior type for our effect, and we're going to specify an opaque behavior. Now, under the opaque behavior, we can now specify body and language. This is going to be important because we need to specify both body and language. So by default, the language is English, for God knows what reason. English doesn't have a specification in Cameo. I've talked to the folks at No Magic, and they say, yep, that's true. We're not going to tell you what aspects of English execute, which aspects don't. But there are a number of action languages supported. Groovy does have a print statement, so we're going to use Groovy for that. Now, because this is executed in a context, we can specify the action. And the action we're going to have is count equals count plus 1. Groovy does not have the notion of a plus plus operator. So we'll just use count equals count plus 1. And then we're going to print count. And so we specify the action language, Groovy in this case, and we specify the body. Click on OK, click on OK. And here we see, now we have our action. So now we can think about running this. We also have to add our default value for count. So we will specify that. And let's see if I can do that just by specifying a slash followed by count equals 0. This ought to work. Click on OK. And now let's look at this transition and the effect. And we see that it did find that was an opaque behavior, and the opaque behavior element was count equals 0. That's going to be in English, but that's okay. You can do an assignment statements in English. That seems to work. So now we should be able to run this. So the print, I expect to go to the console output. That's shown here in the console output, and we should be able to watch this execute. So let's now rerun our simulation. All right, and we're ready to go, and we can run this, and we start in the ready state. And if we look over in the count, we see count has the value 0. That's good, so good so far. Now we can select EV start, and we'll still in the running state, and then we see it in fact is running. Every second is printing an output. I can go back to our context, and I can now do a stop. There we go. There we go. Stopped. Okay, so that's some of the joy that is Cameo. But now we got the machine running in both cases. So this was just meant to be a very short, really elementary video and just getting some states to run. Later on, we'll talk about adding other elements and sending events back and forth between those elements and causing more collaborative behavior. So I hope this was interesting, and we'll talk more later. If you like the video, please click like. If you want to be subscribed to the channel to get notified when additional elements, you can click the notification and subscribe button. Thank you very much.